Hi. You may remember last year I built a machine that tested the excellence of cookies, store-bought cookies, ones you can buy in a grocery store. And it did a fairly adequate job of analyzing the different parameters and ranking these cookies so that we could tell scientifically which was the best. But something I didn't think about when I built that machine was that when I tried to test snack cakes, it just didn't have the machinery inside to evaluate that. And it's been bugging me, so I've torn apart that machine. The only things that are left are the control box, and see, it's empty inside, and the brass flap that I used to put the cookies in. And I don't think I'm going to use that. I think I'm going to repurpose that for something else. But I've conceived a new machine in my mind, and now for you on camera, I will conceive it in reality. So join me as I work my way through making this machine. The first thing the reason I found this, the reason I decided to do this is because I found a PCB in a refuse pile that belongs to a machine that analyzes things. And I thought, okay, I'm going to forego all the vacuum tubes and the hoses and clamps and gears for accuracy. So I'm going to use that PCB, but at first I have to clean it up. So I'll show you what it looks like now. It's kind of muddy and rusty and broken. And I'm going to fix that PCB and then adapt it to this other little module that I found. So I hope you will enjoy this. Let's go. So here's this PCB. I was really excited to find this. You can see it's kind of muddy and rusty. Forgive the footage. This is shot with my phone. You can hear in the background I'm rummaging around in a junkyard. But I was so excited I had to capture this on the day. You can see some of these pins are bent down. I'm going to have to straighten those out. There's missing components. All these I have to straighten up so I can attach it to something. And looks like there's some missing chips, but that's okay. I'm going to repurpose this. But first, I got to wash it off. So I've got this this power washer with an industrial soap in it. Blast it. As you can see, that soap really did a good job, cleaned off all that mud and even some of the rust. There's some pretty gnarly rust on there though. Look at that. Eesh. But I have a plan for cleaning that off, and that is putting it in this little tray that I made and soaking it in vinegar for a few days. Vinegar will gently wash it off. I've heard that you can use citric acid, but I'm going to try this first because this is cheaper and available in the grocery store. And the vinegar didn't take care of all the rust, so I went at it with some heavy-duty steel wool and then washed it off and dried it in the oven. take a look at this now that it's completely, well, it's as clean as it's gonna get. Looks like that's a little bracket there. That came out pretty good. The little bracket. Here's a place where a harness will go. I think I can straighten these out. I'm gonna have to replace at least one of these little capacitors. That one's gone. Right. Yeah, here's a little potentiometer. There's something. Oh, that goes down. I think it goes down there for some. Oh, I bet this is where a battery goes. These, I'm going to have to bend these little posts up so I can connect to the other machine and these posts. This side is a little bit more rusty. Couldn't get the rust off of a lot of this stuff. It looks good overall. Just going to have to bridge these traces between here and here over this crack because they've all been severed by the crack. So there are very many traces. Just take a little wire, solder it there, and then solder it there. Do that all the way down. Doop, 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 doop. I've been stitching this crack together with itty bitty wires, and I thought I'd show you a bit of the process. I'm using this solder paste, this flux, that has two functions. One, it helps me to stick the wire from one trace to the other, and also when you heat it up, it provides a bit more lubrication for the solder to flow. So I'm just gonna stick this down, and I won't be connecting every trace. If you can see the details on this video, you'll see that there's lots and lots of traces crossing the crack, and I'm only going to be connecting a few of them because I only need a few of them for the project that I'm working on. And I'll just show you this one connection because the video is going to probably be kind of long. That one's on. This one's still loose. Okay. It's not pretty, but it will connect all these little traces. So the next thing I'm going to do is I'm going to use some of this JB Weld epoxy to fix the crack, and at the same time glue down these wires so that they're a little more sturdy. They're not going to get yanked off. I'm not going to be jostling this around too much, but at least I want to be sure that nothing comes loose. Alright, then I'm going to pause a little bit and let this epoxy set. But first, I did want to show you what I've been doing. I've been adding these little LEDs here, there, and there. And that way, when I plug this in, there'll be some indications that it's actually working. So these are my test leads. As soon as I get this chip repaired and add the cables to these pins, we will test it. And I'm going to let this set for a while too. So next time you see it, I'll have the cables all set in here, and we'll plug these into the power and see if it works. This thing is called a cardio tack, and what it does is, or what it did was, receive a trigger, an input, and it would measure a pulse, because it was a heartbeat meter. And I'm going to change this to my needs, because I need to be able to measure the excellence of a treat. So I'm going to take this apart, and I have a box of goodies here that I think I can use. This is a great knob. I can't use that for this project, but some stuff in here. I think. Ooh, here's a relay that I could probably use for this project. And what is this? That's not. Oh, this is a videotape head. This reads signals from a videotape, but that's not what I need. Oh, this is a good one. Probably gonna need that. And not this, but maybe this. Yeah, here's another relay. So all these things are going to go in here, and I'm going to take some of these wires here, and some of these little doodads and trinkets and stuff from here, and put it in here. But first, I wanted to take a little view of it for your benefit, so that you can see what's inside one of these things. I've opened it up already, so I know. But it is a beautiful elaborate device. Donk. Look at that. Some vacuum tubes. This is a giant transformer. Mostly vacuum tubes. Here's the back of the selector switch. See, it channels the signal through each one of these different resistors, and that's how you calibrate the strength of the signal. See? And this is the back of the meter. It's a beautiful meter. Want to see what's on the underside? Ooh, more stuff. Look at that. Capacitors. There's the fuse, 2 fuses. Some arrays of resistors. Here's a thing to adjust, calibrate with. And this is interesting. Look at this. See this little knob here on the front? It twists a rod that goes all the way to the back, and that's what connects it to the back of the enclosure. I'll have to take some of this stuff out to make room for the components that I need to create my machine with. And some of them are going to have to be these beautiful little vacuum tubes. See if I can just take this out to take a look at it. Being patient. There we go. That's not a problem. So, for anybody who wants to know, looks like it's a 6BX7GT. Heavens knows what that means. These are very beautiful little things. And, oh, how about let's focus on that, shall we? Yes. And these things were eventually, for anyone who doesn't know, replaced by something like this. Just a tiny little component. Oops. Transistor. So, yeah, I'll be taking this apart, and I won't make you suffer through that. For those of you who treasure these things, it would be painful to watch somebody take apart a beautiful old piece of equipment. But golly gee, look at this. There's a little incandescent lamp just kind of tilted right behind this beautiful little jewel lamp dome. And I think that was added on afterwards, because look, they just drilled right through the name of the model. Obviously it used to say physiograph, and someone says, no, we need a little green light there. So I'll be using some of these knobs. Some of these knobs won't be useful for my purposes, but this switch is neat. Look at that. Oh yeah, that's the other thing I wanted to show you. Look how this switch operates. Let's see if I can. I'm gonna adjust real quick. So this switch toggles between a neutral state
and the beat-by-beat record, which is an algorithm they use to measure heartbeats.
And then recording the mean of signals, which is like a bunch of signals coming in and finding sort of something like the average.
Just a little side path here to show that there is a difference between the words average and mean, but the way they use it in this context is they detect a number of heartbeats in a period of time and determine, okay, this is your heart rate. And you look at it on the little dial there. And they compare it to the beat-by-beat record, which is highlighted here in this scientific paper. And they compare those two, and they see, oh, it looks like there's an arrhythmia, because there's actually more beats in this time period than there are in this time period. So this is how they use this machine to diagnose heart problems. And there's another little spot I went to research this called ResearchGate, and had lots of neat graphs and lots of big words, like the long word that is shortened into EKG. And I love saying it, and I'm going to try to say it right now: electrocardiogram. Okay, back to the disassembly.
And then in the middle, it just sits there waiting. So what it looks like back here is, let's see if I can focus a little bit closer. So the switch, see I'm toggling it here. The switch is neutral here, and it has two of these little tines connected here and here. These little buttons here are carbon pads, so they make connections and they don't wear out the metal too badly. And also, if you look down here, these two tines are connected, and the tines go into this block set so that the metal is separated by from each other. And then when I flip the switch up, this plastic piece here goes down, and it presses two different tines together, you see? So it disconnects these two and connects these two, and does the same up here. There's two up here, watch. Right? And then when I switch it up, it disconnects these two and connects these two. And same thing up here and same thing down there. So all these tines are basically just connections that run to these wires down here to all these components. And what it's doing is receiving signals and doing math with the voltages through the use of these vacuum tubes and capacitors, and there's some resistors in here too. That's all it's doing. It's not doing, there's no computers doing math. It's all using voltages to do math. And it's when you use this thing, you kind of want to know signal B times B and the mean, so that when you look at your little screen, you'll know what your, not screen, meter, you'll know what the signals are doing. Oh, look, there's a cute little lamp up there. So, oh, there's a little lamp down here too. See that little lamp? What do you suppose that lamp was for? It wasn't visible through... Maybe it's not a lamp. Maybe it's just sort of like a diode or something. I honestly don't know what that component is. Little glass component right there. Looks like a lamp, but why would you have a lamp way back there? Maybe it was the previous lamp before somebody installed this one. Don't know. I'll take it out and play with it. But this is what I found very cool. How the old tiny switches worked, and how it measures and does math with electronics. So I'll be taking this apart and constructing a better machine. This is more useful for me in this day when I need to measure excellence. Well, I found a lot of cool components in this old thing, and I thought I'd share them with you. Like this one, I don't know what this is. It has a reading of 100 kilo somethings. Don't know what they are, but it's screwed in. It's bolted in, and it's connected to something, to the rest of it. And this is just an array of resistors. And I think that I had a little... Oh yeah, there's a bulb here that just snapped right off. And this is a resistor, but it's hollow inside. Look, it's just like these this is a resistor too, but this one's packed full of carbon or silicon or something. And this one is just a tube of ceramic. It's called a ceramic resistor. There's some that look like this that are also wound full of wire. It's the same idea. All they do is resist current. So you send in some energy on this side, and then this resists it, and less energy comes out that side. That's the main idea. So it's the same idea with this one. And oh, yeah, here's another, and another. This is how they mark them. 4,000 ohms. This one can't really read. I think it says 1,500 or 1,500 ohms. So this is more resistant to energy, and this one is just a little 500 ohm devil. So this one's less resistant, so it'll allow more volts to go through it. Hey, you know what? Let's just measure it to see how accurate that is, shall we? .475 ohms. So that's pretty close. 475 out of 500. Let's measure this one. This one has a capacitor stretched across it. I'm not sure what that'll do to the reading. Let's read it. I'm going to adjust this. Let's see. 4.12 kilo ohms. So yeah, 4,120 ohms. 4.12 kilo ohms. And this one is in circuit, and I've been instructed not to measure things in circuit because the circuit will mess up the measurements. But let's go look at it anyway. 1,500 is what it says, I think. It's not reading anything. Wait, it's this one. Is it? Ah, here we go. Can you see through my knuckles? It says 1,470, which is pretty darn close to 1,500. So yeah, that's that. I'll unbolt this and see what it is. But before I do that, what else was I going to look at? I had it here. Oh, there. This little bulb here. I told you I was going to look at that. I took it out. And it is indeed a bulb, but it's not a regular bulb. It's a neon bulb. And that's what I think is in the front of the panel too. Let's see if I can see. The neon bulb is different from regular bulb. There's no filament between them, between these two posts, or what are those called? Electrodes. There's just there's neon gas inside that bulb, and the current goes through and charges up this electrode, and then when it gets to a certain point, it hops over and makes a connection through the neon gas, and that's what lights up. So it takes a lot of energy to make this go, and it takes AC energy.
So I tried it at first and it didn't work because it was I just stuck my DC power supply on it. But you know what? I have a thing that'll make that go. Let's try it. Let's try to make this go. Because I've seen these on FranLab videos and they're very pretty. So I'm going to reconfigure here. Hold on. Okay. What we got here is a little transformer with a variable knob on it. It's sometimes called a variac. And I can put anywhere from 0 volts all the way up to 100 volts. Got it? And I plug in a plug to whatever it is I want to power. And right now, that plug is broken out onto this little piece of wood into 3 little wires. So, concept is, I'm going to take these little wires and make this neon bulb glow. And I'll lower the lights for a romantic atmosphere. Hopefully this will focus in the low light. And this is neutral, so I don't need this one. I'll just put this one up here. So, here goes nothing. I should put on some glasses. Yeah, that's a good idea. Okay. So I'm just going to try a very low voltage. It says usually 90 volts is what these things like. I'll try 20 first. Nothing. Not surprising. Now 40. Nothing. Now 60. Yay! That went off. Pretty. So that was 60 volts. Just going to make sure this is in view. Come on, buddy. There, that's pretty. What a pretty glow. That would have been really nice to see inside that machine. Out of curiosity, I'm just going to put it up to 70, see if it glows any more. Oh, there was only one glowing at that time. Now there's 2 glowing. There we go. Oh my God, that's beautiful. So just to repeat that, I'm going to go down to 60 again. Oh, now both are. I guess maybe it just needed to charge up a little bit. But the first time I did it, only one of those bars was glowing. Okay, going up to 80. How about that? 80 volts of energy going into this. Stop rolling around, silly monkey. Actually, pausing for a second. Safer, and you can see the glow. The glow. All right, now I'm going up to 60 again. Isn't that pretty? Pinky. It's kind of pinky. All right, now 80. And it's pink. It's very pink. Oh my gosh, that's so pretty. See, I'm not in a position to see what the what the monitor is seeing, so I don't know if it's showing the beautiful pink color that I'm seeing. Golly. Yeah, it's just gorgeous. Wow. All right, I'm going to take a picture of that. But that's that's what was in there, and that's what would have been showing inside. Okay. Okay, one more thing I wanted to show you. Remember we were talking about this little resistor, ceramic resistor, and I wondered what this thing was. So I pulled it off, and you can see here it says EZ trim, and on the other side there's a symbol there of a wavy line. See that wavy line? And a little arrow pointing down. See that arrow? Right there. That's a symbol for a variable resistor. So the wavy line is a symbol for a resistor, and the arrow means that there's something in the middle that can adjust it. And that's what this little screw is. This little screw, turning it, adjusts the resistance. So on one end, you place the thing you want less energy going to, less current going to, and the other end you put the source of the current, and then you adjust how much current you want going by twisting this little knob, just like this. This is exactly the same thing. This is another one of the things I pulled off of that circuit board, and this is a variable resistor, also known as a potentiometer. There's one end, there's the other end. And instead of a straight path, it's a circular path around here. And you turn this little screw to adjust how much. It's like a little clock face. How much current goes through. So, oh yeah, and just see, there's that sign. There's a stationary, fixed resistor. Like this. That's just a regular old resistor. And this over here is potentiometer. There's a little arrow, just like here. Can't see it because of the darn old shadow. There it is. So let's just go ahead and so I twisted that all the way up to 77. And the other side should be around 25 or so. 39. So I guess that would make this resistor 110 kilo ohms resistance. It's supposed to be 100 kilo ohms. So I suppose that's, I mean, it's within spec, it's within 10%, but that is that. Hi, I realize this video has become quite lengthy, so I'm going to cut it here and do a part 2 next week. And I have to wait for that long anyway because I'm waiting for a couple parts. But before I stopped, I wanted to show you just a couple more things. This is this pretty little green light I was talking about. The incandescent light is behind it and it's shining. It's very pretty. Let me just turn off the light here so you can see it in brighter detail. Isn't that pretty? Yeah. And then I found a nice cable that fits right into trigger input. So that's stuck onto one of my pin sets, and this pin set is just the right size for this. Right? So I'll be sticking that on later, but this is the thing that I need parts for. The other end of this cable, I'm going to be setting a probe onto so I can stick it onto treats and measure them. So there's parts that I'm waiting for that. So in next week, you will see this completely assembled, and we will be testing all sorts of things. Pies, snack cakes, everything sweet. Thanks for sticking around. Bye.